Okay, so the last video that you guys watched was section 9.2, looking at converting moles to grams and grams to moles in stoichiometric problems. And so now we're really going to throw another conversion factor in for you and just take it up a notch if that's okay with you. Today we are going to go from mass to mass. So you're going to start with grams of one substance and convert it to grams of a different substance. So the general guideline here, let me get rid of this. General guideline is you're given mass of a given substance. Your first conversion is going to use the molar mass. So you're going to divide by that molar mass to get to moles. Now you're in moles of that substance, and now you can use the mole ratio. So your second conversion is the mole ratio of your given substance to your unknown substance. And now you have moles of your unknown substance, but they want you to figure out the mass of it. So then you're going to multiply it by the molar mass. So here we're going to divide by the molar mass, and here we're going to multiply. Oh God, that looks like a plus sign. Asterisk. Okay, you guys know what that meant. Anyways, so basically, if I'm given element Z, I start with Z grams. I divide by the molar mass of Z to get 2 moles of Z. Then I can use my mole ratio. So now I'm going from Z to Y. And then they want to know the mass of Y. So you just multiply by the molar mass to get your answer in grams of Y. So let's take a look at some sample problems here. And I just want to make my pen a little bit thinner because we're going to be writing a lot here. Okay, here we go. Tin fluoride is used in some toothpastes. It is made by the following reaction of tin with hydrogen fluoride according to the following equation. How many grams of SnF2 are produced from the reaction of 30 grams of HF with tin? So the first step is make sure you're dealing with a balanced chemical equation. I have one tin on each side, 2 hydrogens on each side, and 2 fluorines on each side. So this is the balanced equation. Second step is start with what you're given. In this case, they are giving me 30 grams of HF. So that's where I'm going to start. All right, so my first conversion factor. The first conversion factor is you want to convert grams of HF to moles of HF. And the only way you can do that is to divide by the molar mass. So what's the molar mass of HF? Hydrogen, I got 1 at 1.01. And fluorine, I got 1 at 19. Add it up, 20.01. So, and then grams of HF, that 20.01 goes on the bottom, so it will cancel out. If I measure out 20.01 grams of HF, I have a mole of HF. Okay. Now my second conversion is the mole ratio. I'm going to go from moles of HF to my unknown. They want to know tin fluoride. Okay? To figure out your mole ratio, you're using the chemical equation. So here's HF, 2 in front. Here's SNF2, the 1 in front. I'm in moles of HF, so moles of HF go on the bottom, but it's going to be 2 moles of HF. And I'm converting that into 1 mole of SNF2. All right, 2 conversions down, 1 more to go. I'm in moles of tin fluoride, and I need to figure out how much grams I can make from this. So you need to find the molar mass of tin fluoride. So tin, SN, periodic table, 118.7, I got 1 of them. In fluorine, I have 2 at 19. And I add them out and get this out of the way. Get 156.7 grams. Okay, so I'm in moles of tin fluoride. That means moles goes on the bottom. It will be 1 mole. of SnF2. 1 mole of SnF2 is 156.7 grams. Okay, I've set it up. There's my 3 conversion factors. Molar mass of my given, mole ratio, molar mass of my unknown. Notice that my units will cancel out. Grams of HF will cancel out. Moles of HF will cancel out. Moles of SnF2 will cancel out, and I will be left with grams of SnF2. I honestly don't know what I hope I said the right thing. Anyways, 30 times 1 divided by 20 times 1 divided by 2 times 156.7 divided by 1 gives me 117.47 grams of SnF2. There's my answer. Woo! Isn't this fun? Okay, moving on. Okay, so I'm being really mean, not giving you a chemical equation here. When sodium chloride reacts with silver nitrate, silver chloride precipitates. What mass of AgCl is produced from 75 grams of AgNO3? So the first step is we got to figure out what this chemical reaction looks like. Sodium chloride reacts with silver nitrate. All right, sodium chloride. All right, that's NaCl. And it reacts with silver nitrate. And silver nitrate is AgNO3. We did this in our lab, but silver is Ag. Nitrate is a polyatomic ion with a -1 charge, so it's AgNO3. What mass of AgCl is produced? So, arrow, AgCl plus, because I'm missing something here. All right, so I'm missing my NO3 and my Na, so those two must be together. Na, NO3. And this does work. Sodium's got a +1 charge, NO3's got a -1 charge. Makes sense. That's some type of salt would be produced there. Okay. Is this balanced? Yeah. Got Na on each side, an Ag on each side, a Cl on each side, and an NO3 on each side. So I have a balanced equation. All right, now I can start setting up my stoichiometric problem here. Start with what you're given, 75 grams. Okay, so 75 grams of AgNO3. Now, your first conversion is to convert grams to moles of AgNO3, and the only way you can do that, find the molar mass. So, Ag, I got 1, and if I look on the periodic table for Ag, it's 107.9. Nitrogen, I have 1 at 14.01. Oxygen, I have 3 at 15.99. I add all of these up, 169.88 grams per mole. So if I measure out 169.88 grams of silver nitrate, then I have a mole of silver nitrate. So I'm in grams of HgNO3. That means grams goes on the bottom, so it can cancel out. This goes on the bottom. This is equivalent to 1 mole of HgNO3. My second conversion is the mole ratio. So I'm in AgNO3, and I want to get to, in this case, they want to know AgCl. This is what mass of AgCl. Okay, so before I can figure out mass, I got to do moles. That's the only way you can go from one substance to another in stoichiometric problems is using the mole ratio. So to find the mole ratio, you got to use the chemical equation. I'm in AgNO3. There's a 1 here. I'm trying to get to AgCl. There's a 1 here, so it's going to be a 1-to-1 ratio. So 1 mole of AgNO3, that means 1 mole of AgNO3 has got to go on the bottom so it cancels out to 1 mole of AgCl. All right, my final conversion is to figure out the mass of AgCl by multiplying by the molar mass. So, silver. What's the molar mass of AgCl? I got 1 at 107.9. Chlorine, I have this one memorized, 35.45. Add them up together, 143.35 grams. So 1 mole of AgCl3, 1 mole of AgCl, that means that goes on the bottom, so moles will cancel out. I'm in moles, whatever unit you're in, that goes on the bottom. 143.35 grams goes on top. And my units will cancel out, okay? If you want to check yourself, before you punch it in, make sure your units cancel out. Grams of AgNO3, yep, that's going to cancel out. Moles of AgNO3, yep, that's going to cancel out. Moles of AgCl, yep, that's going to cancel out. I'm left with grams of AgCl. That's what we want. Punch it into calculator. 63.29 grams of AgCl. All right, one more problem. Mass of aluminum is produced by the decomposition of 5 kilograms of Al2O3. Oh boy. All right, so decomposition of Al2O3. So I got to write my chemical equation. Al2O3. Decomposition means it's going to break down into its parts. So I have AB, arrow, breaks down into, A plus B. So breaks down into Al plus O. But then you say, wait a minute. O can't be by itself. It's got to be O2. Right? So put 2 here. Now, is this balanced? Heck no, it's not. Looks like I might have some problems with my oxygens balance in here. Because, if I balance this real quick, I'll just write it right here, and then I'm probably going to erase it. I got this odd-even thing going on here, so I can figure out the common number that both 3 and 2 go into, and that's 6. So if I stick a 2 here, 2 times 2 is 4. 2 times 3 is 6. Come back over here, I put a 3 to get the 6, because 3 times 2 is 6, and then I put a 4 here. And if I look, it's balanced, and not only that, you can't reduce it. So I know I did it right. Okay. So now I can go on to my stoichiometric problem here. This one's unique. I'm actually going to do 4 conversion factors. I'm just going to do it all in one string, just to prove to you how cool stoichiometry can really be. So they say, start with what you're given. I'm given 5 kilograms of Al2O3. Now, some, bell should be going off here. Kilograms is not the same as grams. Okay? So I have to convert kilograms to grams. So I'm actually going to set up a conversion here right off the bat to convert from grams to grams. I'm in kilograms, so 1 kg, that's the bigger unit, goes on the bottom. And I know that there's 1,000 grams in a kilogram. So now I'm going to be in grams of Al2O3. Okay, now we can resume to our previous conversions. So I have grams of Al2O3. I need to convert that to moles, so I can use the mole ratio. So we convert from moles to mole ratio, and then molar mass if you're unknown. So I got to figure out the molar mass of Al2O3. Oops, I meant to slide this over. So Al. 2, look on the periodic table, 26.98. Oxygen, 3 at 15.99. Add them up. Slide this out of the way. 101.93 grams per mole. So if I measure out 101.93 grams of Al2O3, that means I have 1 mole of Al2O3. So I'm in grams. That means the molar mass goes on the bottom. 101.93 grams of Al2O3 gives me 1 mole of Al2O3. All right, I'm in moles finally. Woohoo! Now I can use the mole ratio. I'm going from Al2O3, and they want to know what's the mass of aluminum. Okay, so go to my chemical equation. All right, I got a 2 to 4 ratio. Now, because I'm in moles of Al2O3, that means moles of Al2O3's got to go on the bottom. But I'm going to put 2 moles of Al2O3 to 4 moles of aluminum or aluminium. All right, there's the mole ratio. Now my final step is to convert moles of aluminum to grams of aluminum. How do I get that? I use the molar mass from the periodic table. So I'm in moles of aluminum. That means that goes on the bottom. 1 mole of Al. What's the molar mass of Al? Look on the periodic table, 26.98. Now I'm going to check myself before we wreck this, right? I'm in kilograms of Al2O3. That's going to cancel out here. So now I'm in grams. To get out of grams, I'm going to divide by molar mass. Now I'm in moles of Al2O3. I use the mole ratio to get out of moles of Al2O3. Now I'm in moles of aluminum. To get out of moles of aluminum, multiply by the molar mass of aluminum. So 5 times 1,000 times 1 divided by 101.93 times 4 divided by 2 times 26.98 divided by 1 gives me a whopping 2,646.9 grams of aluminum. Whew. Okay, so we just did mass to mass stoichiometric problems here. You do have an assignment. Again, attempt it. Bring your questions tomorrow to the Zoom session or the next time I see you, or feel free to email me, remind me, contact me in any way. Let me know if I can help you out. Actually, I do have one more thing to show you. And I'm not sure if it's going to work. But we'll find out. This is actually really, really bad. Sorry. You know me and my cheesy videos.
Stoichiometry rules. Watch the fools who don't learn about it in the schools. It deals with moles and parts of holes. Get your calculator or be eaten by trolls. Show the math, reveal the path. When you get it right, then you can laugh. If you got a bunch of grams, moles is what must be. If I what you got my formula mass, and that looks right to me. You got liters of an ideal gas, want to change it into moles. Divided by 22.4, you can make your compounds. If you got atoms or molecules, and moles is the good word. Divided by 6.02 times 10 to the 23rd. Oh yeah. It deals with moles and parts of holes. Get your calculator or be eaten by trolls. If you want to go the other way, from moles back to what you said, any of these, what can you do? Just multiply instead. Drive a molar miles in your car. How far you think you drive? 100 billion light years takes forever at 55. If you had a mole of dollars, folks would cry unfair. You'd be the richest person. You'd be a millionaire. Oh yeah. Stoichiometry rules. Watch the fools who don't learn about it in the schools. It deals with moles and parts of holes. Get your calculator or be eaten by trolls. Show the math, reveal the path. When you get it right, then you can laugh. Ha ha!
Yeah, if that doesn't brainwash you to think stoichiometry rules, I don't know what else will. To tell you the truth, in the old curriculum, we actually did like liters of gas to liters of a different gas, and this book cuts that out. So I don't know if it's going to reappear later on or not. So you can count yourselves lucky. Yeah, this is not as thorough as our last curriculum. But anyways, contact me if you have any questions.